Hello everyone, welcome to my YouTube channel Tech Pe Charcha with Dpwala. Hope you all are doing good. So welcome back to this new initiative which I have started of solving Leetcode blind 75 problems. So what we will be doing in this initiative is like I will be explaining all the blind 75 problems from the Leetcode. When you talk about Leetcode blind 75, it is one of the best resources and a go-to resource for an individual when he or she is preparing for the interviews. So before the interviews, we won't get that much time to resolve 200, 300 problems. So just before the interview, if you want to revise all the concepts and want to cover good amount of concepts and want to do hands-on on some of the problems. So LeetCode Blind 75 is one of the best resources. So I'll be explaining all the 75 problems. You will be getting this inside a single playlist. So that will be very easy to access, and I think that will help many to uh, solve the problems and prepare for the interviews in a well manner. So let's get started with the very first problem, that is longest consecutive sequence. So here, I won't be showing the code directly. First, we will build the intuition. We'll be explaining time complexity and all as well in the entire playlist. So that will be a good thing as per interview point of view. So here in this problem, longest consecutive sequence, we are given an unsorted array of integer nums. We need to return the length of the longest consecutive element sequence. We need to write this solve this problem in O of n time. So basically what they are trying to say here, we need to find the longest consecutive sequence. So you can see like 1 2 3 and 4 is the longest one. So array is unsorted, they clearly mentioned, and we need to find the longest consecutive sequence. So when you talk about this problem and when you're preparing for interviewer or when you are explaining this question, so basically you must tell the brute force solution first. So the brute force is very simple here. We can sort the array and we can start from the first element itself and till we'll go till the next elements, like when it is in increasing order and when it is consecutive. So sorting will leads to n log n complexity. So but we want to solve this in O of n, so we need to think in a better manner. But you need to tell the brute force solution first and then come to the optimal approach. So let's discuss this problem. Uh, so what we are given 100, we are given 4 200 132 4 4 200 and 132. So when we talk about this array, so the best approach that can be doable here is like what we can do is like we can insert the entire this array elements into the hash set, or we can say unordered set in C++, hash set in Java. So basically what we will do, we will our set contains all the elements 1 2 3 and 4, 200 and 200. So what we'll be do, we will be traversing over each element of the set then. So let's say we are at the very first element, let's say 1. Assume it like we have a set, we will traverse over the set elements, and this is our set, let's assume. And what we'll be doing, we will traversing over the first element, that is 1. What we will do, we will maintain a counter variable that is 1. uh, C is equal to 1 because we have one element, and we will run a for loop till we get a consecutive element. So the first element will be this, the next element will be 1 plus 1, that is 2, right? So we'll be searching 2 in the set. Whether we have 2 in the set, yeah, we have 2. Then our count becomes 2. Now then what is the next element after 2? It will be 2 plus 1, that is 3. We will be searching this 3 in set. Whether we have 3. Yeah, we have 3. So we will be incrementing our counter to 3. Then what is the next element after 3? It will be 4. Do we have 4? Yeah, we have 4. Here you can see. So our in count will be increment to 4. Then we will be moving to 5. Do we have 5? No, we don't have 5. Our while loop will break here now. And our max count that we got till now is 4. And we'll be storing like max variable which will store the answer. So currently we have 4. Then we go to the next element, that is like 2, let's say. So do we have to? Yeah, we have. But we go to 3. We have count 2. Then 3, the next element of 3 is 4. We have count 4. So basically, uh, the count for this when we start at 2 is it will be 3. But this is not our max because we already got the max, that is 4. Similarly, this will go till 4 and that's fine. Then the next element will be 100. What is the next element after 100? It will be 101. Do we have? No. So that will not lead to the max value. Then 200. We don't have 201, so count will be still 1. And hence we got a max value of 4. So basically what we are doing here, we are first inserting all the element into the set. Then uh, we will be taking each element at a time in the set. Let's say our first element is 1. So we will be moving till when we get the consecutive valid consecutive elements. So 1, we will search 2, we will search 3, we will search 4. We got 4 consecutive elements. We'll be maintaining a count, and we will maintaining a count, and we'll be maintaining a max length as well, and we'll be storing that. Here we got 4. So basically, for inserting all the elements in the set, we you can run a for loop for the entire array elements. That will be done in O of n, and then we will be traversing over each element of the set and traverse till its consecutive elements. So it can be easily done in asymptotically manner in O of n time complexity. So let's see the code, how it can be done. So this I have done in C++. So what as I mentioned it at the start, we'll be having a unordered set at the start. Basically, I have, for the explanation purpose, I have started with 1. Array contains asset contains element in unsorted as well, but we'll be moving in each element at a time in the set because sorting doesn't make sense here and it's not required because we just need to check the next elements whether it exists or not. So basically I insert all the element into the unordered set, then we have all the array elements in the set now. And basically I have maintained a longest sequence length which will store the length of the longest sequence. We will go to the very let's say we will check like whether we encounter the previous element to this array. Let's say this condition I will explain to you. So basically as we discussed, like every time we need to go over each element of the set. So basically we will go to 1, 3, 1, 2, 3, 4, and again when 2 comes it will go to 2, 3, 4 again, but that will not lead to the maximum value. So basically let's say if we have 2, let's say we are at 2, if we have 2, so whether to search for the longest length starting at 2 is valid, we need to first check like that whether we encounter the its previous element earlier. If we encounter means this has been covered in that previous element because let's say 1. So this 2 has been covered in 1. No need to search further because if its previous element has been covered means as both are consecutives, that has been covered. So this will save our time rather than searching every time. That will lead to O of something kind of n square asymptotically. So to avoid that, to come up with the O of n solution, this condition is required. So for every element in the set, we will checking that whether we have that previous element or not. Here we didn't encounter the previous element, then only we will search. So let's say it will search, it will mark the current element as element, maintain the counter because that current element needs to be counted. Then we will check that whether it's +1. Next element is consecutive element is present in the set. If it is present, increment the count, in, increment the current element as well, because we need to search the next consecutive element. And at last, we will be storing it in the max count. So at the end, we will be returning longest sequence. So the thing which I also encountered, like if you don't write this condition, it will basically result into a kind of brute force solution only, or we can say worse than brute force, as worse than the 10 log n solution. So that will not be a good way. So basically, to optimize it, we need to check the previous element. If that previous element doesn't exist, let's say for 2, previous element is 1, it exists, means that 2 can be will be counted and has been counted in that 1 itself, in that longest sequence. So no need to check further if it exists. If it doesn't exist, then you need to check, because you don't know that whether that will lead to longest length or not. So in this manner, we can do it easily in O of n, and this is a very good question. It seems to be very easy, but you can even see like acceptance rate is 47%, because lot many people can be easily do it in O of n log n, but to come up with a solution which can be done in O of n, need to take care of this. Here we haven't done any sorting kind of thing. We have just implemented O of n log n solution. I am talking asymptotically. It can be slightly higher, but it is asymptotically O of n. Hope you like this video, and hope this question is clear to you, and how to explain this question to the interviewer when you're preparing for the interview. So basically, read the problem carefully, first step. Second step, uh, think in terms of the what will be the brute force. Explain your thought process to interviewer, and then come up with the most optimal solution, as we have done. At the start, I have explained you like how to you can explain with the help of pen and paper to the interviewer, then come up with the time complexity and write the code in a well manner. Always try to use a good naming convention in your codes, and so that it can be helpful for the one to understand the code. Hope you got the intuition behind this problem, and hope this will be helpful. So stay tuned for more such next useful questions from the blind 75. I will be explaining every problem, and you can find it in my playlist. Thanks for watching this video, and happy coding.